inverse?
The first thing we're going to be talking about in Unit 5 is inverse. Inverse is basically finding the opposite of the equation that is given. So we're going to start off by finding the inverse of a log. The first step is to switch the f of x to y. The next step is to switch x and y and have it set to x equals. You then take the log and set it back to exponential form, and then you have to do the fourth root to cancel out the exponent that's with the y, and that leaves you with the final answer, which would be y equals the fourth root of 8 to the x.
Properties of exponents.
These are the properties you will use when you're working with exponents. With the product of powers is when you're multiplying exponents, so you would add them. When you're dividing your exponents, you would subtract them. When you have a negative exponent, you would put 1 over it to make it a positive, because you can't have a negative exponent. When there's parentheses and you're multiplying exponents, all you do is just carry it over, so it'd be x m times n. When you have a power of a quotient, you would carry it over to both exponents, so it'd be x m to the p and x n to the p. For power of a product is the same way. You would just carry the exponent over, but to both of them. And for a zero exponent, anything that's raised to the 0 power equals 1, and x would not equal 0. This is the exponent form, which is x to the 2/3. And to change that to a radical form, you would keep your numerator and make it x squared, and you would put your denominator on the outside of the radical.
Exponential equations.
Our third topic in Unit 5 is how to solve exponential equations. When you're given a problem that has two numbers of the same base, you drop the bases and set the exponents equal to each other. So here I've subtracted 3x from this side to make it so x is only on this side, and we now have 2x plus 10 equals negative 4. I then subtracted 10 on both sides and canceled out the 10s, so it's 2x equals negative 14, and I got x equals negative 7. Another way you could be given an exponential equation problem is with there having two different bases. So as you can see here, we have 81 and 9. So since 9 is the smallest number, we're going to try to find a way to make 81 down to 9. And 9 squared is 81. So we put 9 squared in parentheses. And now we both have the same base. So we can drop the base, and we distribute the 2 that's the squared here to the exponent. So it becomes 2x minus 8 equals the 3x from this exponent. And when you subtract 2x over here, you're left with x, and x equals negative 8.
Properties of logs.
With properties of log, we have expanding and condensing. And our example here is when you're multiplying within the log. When you multiply within the log, you would change it to adding with the product rule. So it'd be log base 10, 3 times 4 would be log base 10, 3 plus log base 10, 4. You would keep the bases the same and just add. For condensing is you're trying to get this formula back down to this formula, and we know that with adding you would multiply, so it would be log base 4, 3 plus log base 4x, and that would be log base 4, 3 times x. When you're subtracting, you would divide, and when you're dividing, you would subtract on this side.
Solving exponential logs.
Another part of Unit 5 is solving for exponential logs. So the first thing we're going to talk about is how to take a problem that you're given in exponential form and change it to log form. So the first step is to write log. Then you're going to take the number right here and set it as your base of the log. So it's log base 3, and then you'll take the answer here and crisscross and put 9 here equals x. So we have base, base, and we crisscross sides. The next thing we're going to talk about is how to solve for x when you're given log. So what you're going to do is take log 4 and divide it by log 2, and that will give you x. So this log 4 divided by log 2 is your exact answer. And when you plug that into the calculator, you're given x equals 2, which is your approximate answer.
Log applications.
For log application, we have 4 formulas. The first one is growth factor, which is y equals a times b to the x. And y is your new value, and a is your initial value, where b is your growth factor and x is your time. Then we have growth or decay, which is y equals a times 1 plus or minus r to the x. And y is your new, a is your old, r is your percent, and then if you're adding, it's growth, and if you're minusing, it's decay, and x is your time again. For compound interest, we have y equals a times 1 plus or minus r over n to the nx. And all of them are the same except n, and n is the number of times in a year. For continuously, we have y equals ae to the rx. Y is your new, a is your old, r is your percentage. E, to find in the calculator, you do second, divide, and then second, ln, and x is your time. I have an example of this, and it says a laptop is bought for $2,000 and depreciates at a rate of 24%. How much is it worth in 6 years, and how long till it's worth half its value? To find how much it's worth in 6 years, you would use your decay formula, which is y equals a times 1 minus r to the x. You would plug in all of it, which would give you y equals 2,000 times 1 minus 0.24 to the 6th, and when you put that in the calculator, that gives you $385. To find how long till it's worth half its value, you would do the decay formula again, plug all of it in, and it would be 1,000 equals 2,000 times 1 minus 0.24 to the x, and when you solve that, you get it to an exponent, and then you would put that into log form, and it'd be log base 0.76 to 0.5 equals x, and when you put that in the calculator, it would be 2.5 years, and to put log into the calculator, you would do math up arrow A.
Graphing exponential functions.
When graphing exponential functions, you're going to have vertical translations and you're going to have horizontal translations. So when you're given the equation g of x equals bx plus c, c controls whether you're going up or you're going down. When you have a plus sign next to the c, that shows you that you're going to go up so many times. And when you have a subtraction symbol, that shows you that you're going to go down on the y-axis so many times. With the horizontal translations, when you're given g of x is equal to b to the x minus d, when you're given an x minus d, you're going to go right however many d is. And when you're given x plus d, you're going to go left d units. So our equation given for this line is f of x equals 2 to the x plus 3. So what you're going to do to figure out how to graph it is look at this last number, which is your horizontal asymptote, and it's 3. So you go up to 3 on the graph and draw your dotted line. Your line that you draw has to be above that line, so you draw your arrow pointing upwards because the equation is growth, and you find the domain of the line is all real numbers and the range is 3 to infinity.